Sir, your voice is not audible, sir.
No.
No,
Now are you hearing my voice? Is it audible? Is it audible?
no, sir.
Okay, I will log out and log in. Is it clear? Shall I
Yes, sir.
start? Okay, I'm recording. Don't stop recording. Okay, it's already started recording. Don't stop recording. Okay, so the next is the classification of embedded system. Okay, in the last class we discussed about what do you mean by embedded system, definition of the embedded system. Okay, and next is what we discussed. We discussed about the difference between the embedded system and general purpose computer. We discussed. Okay, and next what we discussed? We discussed about the types of how we categorize. We categorize as four types. Classification of your embedded system as four types. One is called based on the generation, based on the complexity and performance, based on the deterministic behavior, and the triggering. Okay, now I'm going to discuss about the classification of embedded system here. Okay, is it clear? Are you able to see my screen and audible? Audible.
Yes, sir.
Okay, so now the classification of embedded system. Okay, now I'm going to discuss about the classification of embedded system here. Okay, that is actually I'm going to discuss the classification of embedded system only and based on two categories. One is called based on the generation, another one is called complexity and performance. Okay, we are going to discuss the classification of embedded system. One is based on the generation of the embedded system. Other one is called complexity and performance here. Okay, based on the generation, we have a first generation, second generation, third generation, and fourth generation we have. Okay, we have four generations we have in the embedded system categorized based on the generation, and we next is types based on the complexity and performance. Okay, based on the complexity and performance is nothing but again it is small scale embedded system, medium scale embedded system, and large scale embedded system. Okay, we categorize based on the performance and complexity. That is small scale, medium scale, and large scale embedded system here. Okay, so now let's come to the point, the classification of embedded system based on the generation. Okay, based on the generation is nothing but let me discuss what do you mean by first generation embedded system. Okay, first generation embedded system is nothing but it is going to we are going to use the 8-bit or 4-bit microprocessor or microcontroller. Okay, 4-bit or 8-bit microcontroller is nothing but here in the 8-bit or 4-bit microcontroller is nothing but we are going to use the types here. Okay, 4-bit or 8-bit in the sense as we know how many bits. Bits is nothing but either 2 or sorry 1 0 and 1. Okay, 0 and 1 we call that as a bits. Okay, but it is 4-bit or 8-bit microprocessor or microcontroller in the sense. Okay, it is to going to perform the ALU operations, nothing but arithmetic and logical operations 4 bits at a time or 8 bits at a time. I have to miss 8 bit in the sense combination of 8 zeros to 8 1 or 4 zeros to 4 1 here. Okay, nothing but 4-bit and 8-bit in the sense the microcontroller it is going to perform the ALU operation. What do you mean by ALU operation? What do you mean by ALU operation? What do you mean by ALU? ALU is nothing but arithmetic and
Arithmetic
logical
logic
unit.
unit.
Okay, arithmetic and logical unit, nothing but I can perform addition, subtraction, multiplication, or logical AND operation, logical OR operation, inversion operation. That is what we call that as an ALU here. Okay, so here 4-bit or 8-bit first generation microprocessor and microcontroller, in the sense this processor or microcontroller, it is going to perform 4 bits or 8 bits at a time. The operation of ALU, it is going to perform 8 bits or 4 bits at a time. Okay, that is what we call that as 8-bit or 4-bit microcontroller or microprocessor. Okay, and circuit complexity is not very, the circuit complexity is very simple, not very much complex. Okay, the circuit connection in this generation, the circuit connection is very simple. Okay, the circuit connection is very simple here. Okay, so that is what we call that as a first generation embedded system here. Okay, example for your first generation micro embedded system is nothing but digital telephone keypads, stepper motor. Okay, all these are all examples for your embedded system here. Okay, digital telephone keypads, as we seen before, whatever the smartphone you are seeing, all the smartphone will have soft keypads. But before the soft keypad, we have hardware keypads. Okay, we are going to press the number, we are feeling physical touch. Okay, we are feeling the physical touch between the numbers and whatever we are going to dial in the numbers. Nothing but we call that as a telephone keypads. Okay, means whatever you are going to press nowadays, all the mobile phones coming with the soft keypads. Before that, old mobiles, whatever you see, are lower version of your mobile, you will feel the physically you can feel, physically you can touch the keypads. Okay, physically you can touch the keypads. That is the example for your first generation computer embedded system, as well as stepper motor here. Okay, the next is second generation. Second generation in the sense, here it is going to perform 16-bit microprocessor or microcontroller. 16-bit in the sense what? I can perform the ALU operation of 16-bit at that time. Okay, that is what we call that as 16-bit microprocessor or microcontroller here. Okay, 16-bit microprocessor or microcontroller is nothing but I can perform the ALU operation of 16 bits at a time. That is what we call that as a 16-bit microprocessor or microcontroller. That type of microcontroller or microprocessor comes under the category of second generation embedded system here. Okay, if the more bits, if the microcontroller microprocessor, it has to going to perform ALU operation for more bits, is nothing but complexity of the circuit keeps on increases. Okay, complexity of the circuit, it increases here. Okay, the as you compare with the first generation, the circuit connection is very simple. But if in the 16-bit or second generation embedded system, the complexity of circuit, it increases. Why? Because I need to perform 16-bit ALU operation. That is what we call that as a second generation here. The example for a second generation is nothing but data acquisition systems, SCADA systems. All these are all example for your second generation computer or embedded system. Embedded system is nothing but we also call it computer. Okay, nothing but depending on the bits. Okay, embedded system is nothing but what? Your computer itself, no? Okay, is it clear? Is it clear?
Yes, sir.
Okay, the next is the third generation embedded system. The third generation computer system is nothing but again much more complexity is increases compared to a second and first generation. We have a specific chip for each functionality. Okay, we have a specific chip or IC. We have a specific chip or IC for each functionality of my embedded system. Okay, that is what we are going to use called third generation computer. For each and every applications, we are going to use the specific IC in order to perform the specific function or the task. That is what we call that as a third generation computer. If you compare your the 3G mobile and 4G mobile, which is better you feel?
4G.
Why 4G? Because it is fast and reliable. Okay, nothing but you are going to see more faster compared to a 3G network or mobile. Okay, so here also in the same thing in the embedded system, the third generation embedded system is nothing but for we are going to use the different ICs for specific functionalities. The IC may be your digital signal processor or maybe your ASIC application specific integrated circuit. All these are all IC. Okay, we are going to use the specific IC for the specific task or specific functionality. Okay, and if we are going to use the specific processor or microcontroller, along with that the complexity, obviously we are going to get more complexity in the circuit as well as the instruction set. Instruction set is nothing but what? We are going to use this instruction set for my program. Okay, instruction set is nothing but this instruction set I am going to use to create or to write my program. Program may be your C language, assembly language. Okay, all these are all programs whatever you are going to write by using the instruction set. Okay, so if I in the third generation computer, more and more specific IC we have as well as we get more instruction set. Instruction set becomes complex, nothing but why we are going to use instruction set because to write the program. Okay, the program is nothing but your C language or assembly level language. Assembly level language is nothing but low level language. Okay, assembly level language is nothing but low level language it is. Okay, and as well it is more powerful compared to your first and second generation embedded system here. And in the third generation, again one more concept they introduced called pipeline. Pipelining is nothing but parallel execution of instruction. Pipelining is nothing but parallel execution of instruction. Okay, in the program we have what? In the program we have instruction sets. Okay, in the program because if I want to write the program for addition means what? I am going to write, for example, C is equal to A plus B. I want to write the program in C language means I have to declare all these variables in A, B, C. After that, I am going to perform C is equal to A plus B addition operation. For each and every statement, there is a specific instruction. We call this as an instruction set or statement, functional program statement. Okay, we call this each instruction set, we call this as a program statement or instructions here. Okay, so if I want to execute all this statement or instruction means the one more concept, the new concept they introduced called pipeline. Pipelining is nothing but it keeps on execute the instructions. Whatever you see, if I call this is my program, if I call this is my program, in my program I have an instruction sets. Okay, I have instruction sets. Instruction set is nothing but I need to execute my functionality of my program. Okay, so in order to execute the one more concept they introduced called pipelining. Pipelining is nothing but parallel execution of instruction. It keeps on executing. Whenever I am going to introduce pipelining, obviously the performance is increases. Performance is nothing but what? Speed. Your speed or performance is increases in the third generation. Okay, by introducing the pipelining concept. Pipelining is nothing but parallel execution. Simultaneously, it keeps on execute your instruction. Okay, that is what you call that as a pipelining here. Next is fourth generation. Fourth generation is nothing but system on chip. What happens when you come into the when you if a more and more complexity is increases, if the complexity is increases for one generation to another generation, what will happen? It whatever we are going to use single ALU in the first and second generation, I am going to use only one single ALU, nothing but CPU, nothing but in this fourth generation, I am going to consider if this is my IC, I can use multiple CPU. I can use multiple CPU in this IC. If I call this is my integrated circuit, in this IC, I can implement multiple CPU. That is what we call that as a system on chip. System on chip is nothing but what? We can, instead of using one CPU in first or second or third generation, I am going to implement more CPU in single IC. More CPUs nothing but what? More number of ALUs. More number of ALUs. That is, I can implement in the fourth generation. Obviously, what happens? If you increase the ALU, obviously it becomes high performance. High performance and tight integration. Tight integration in the sense, I am going to implement more and more number of CPUs, nothing but what? It is going to integrate, nothing but I am going to keep my CPU in the same chip. That is what we call that as an integration. Okay. So this is what about the generation of your embedded system. Is it clear?
Yes, sir.
What? Sleeping? Sleeping or what?
No, sir.
No, sir. Understood.
Okay. So the next is classification of the embedded system based on the small scale, medium scale and large scale embedded system. Okay, so again, I am going to categorize my embedded system based on the small scale, medium scale and large scale embedded system. Again, small scale in the sense very simple functionality. Again, as I told, we are going to use the 8-bit or 16-bit microcontroller in my application or in my design. If I use 8-bit or 16-bit microcontroller, okay, that is very simple application. In this, we are going to use very simple applications. Okay, the simple application, if I want to build the simple application, nothing but your electronic toy or your chocolate vending machine. Okay, chocolate vending machine means whenever you insert the coins, it will give the chocolates, automatic chocolates. Now, automatic in the sense, as you know the ATM, no? If you insert the card, it will you can withdraw the amount. In the same way, whenever you insert the coins in the chocolate vending machine, it will give the chocolate as a outputs. That is what we call that as a chocolate vending machine here. Okay, here in the small scale embedded system, we are going to use the simple applications. Yes, and performance. We are not focusing more on the performance parameter. We are not focusing more on performance parameter. Okay, the performance parameter is doesn't matter in this small scale embedded system here. Okay, and in the small scale embedded system, we are not going to use operating system. Operating system in the sense what? As you see in the laptop, you have Windows, Linux, in the Mac OS, all these are all Android, all these are all operating system. But in this small scale embedded system, we are not going to use any operating system. It is not required, the operating system in the small scale embedded system here. Okay, the example for your electronic toy, chocolate vending machine, all these are all the example for your small scale embedded system here. Next is medium scale embedded system. Medium scale embedded system is nothing but the complexity is increases. Means complexity in the sense it requires more number of hardware. Okay, whenever the hardware is increases, obviously there is a complexity in the hardware is increases. As well as the firmware. Firmware is nothing but what? As I told, software. Firmware is nothing but software. Whatever you write the program, that is what we call that as a firmware. Okay, the firmware it is not able to modify by the end user. End user cannot modify. That is what we call that as a firmware here. Okay, and here and again we are going to use what type of microcontroller? We can use the 16-bit or 32-bit microcontroller. In the medium scale embedded system, I can use the 16 or 32-bit microcontroller or microprocessor. By using this, if I build my application, such type of embedded system, we call that as a medium scale embedded system here. Okay, and here in the medium scale, it may contain operating system or may not be. Okay, it depends on the requirement. We are going to use the OS. OS is nothing but we can use the operating system in my application in embedded system application depending on the design and requirement. Based on the design and requirement, we can use or we cannot use the OS in the medium scale embedded system here. Okay, and next is large scale embedded system. Large scale embedded system is nothing but again much more complexity compared to a medium scale embedded system. Again higher complex hardware and software that is required. That is what we call that as a large scale embedded system. Okay, here we are going to focus on the performance parameter. Performance parameter is very important. Performance parameter is very important in the large scale embedded system. Performance in the sense what? Speed. Speed should be mandatory. Means speed. We are going to more on performance in the large scale embedded system here. Okay, and here we are going to use what type of processor? Multiple processor or multiple control? Multiple processor, multiple control in the sense, if I take this is my IC. In this IC, I can have more number of CPU. CPU is nothing but what? More number of ALUs in a single chip of IC. Whatever you see nowadays in the laptop, dual core, quad core, okay, all this nothing but what? It contains 2 CPUs or 4 CPUs. Dual core is nothing but it contains 2 CPUs. Dual means what? 2. Quad core is nothing but 4. Okay, so nothing but in this for a large scale embedded system, we are going to use the combination, multiple combination of CPUs because the more and more complexity in the hardware. That is what we are going to use more CPUs in a single chip of IC. That is what we call that. That is comes under the category of large scale embedded system here. Okay, and here we are going to use operating. That operating system is nothing but we call that as a real-time operating system. RTOS. Okay, here whatever the software means whatever the operating system I'm going to use, that operating system name is real-time operating system. Okay, in our laptop, Windows or Linux, Mac OS, or in a mobile phone, Android, whatever, all these are all OS only. Similarly, in the embedded system, if I use OS, the name of the OS we call that as a RTOS. RTOS is nothing but real-time operating system we are going to use in this application, in this category of the embedded system. That is what we call that as a large-scale embedded system here. Is it clear? Is
Yes,
it
sir.
clear? Okay, the next is the applications. As I told, the application is nothing but we are going to use and home appliances, banking, networking, security, defense, aircrafts, okay, consumer electronics, automotive industries, every in healthcare systems, Okay, every field we are going to use this embedded system. Okay, consumer electronics is nothing but what? About gadgets, mobile phones, camcorders, cameras, all these are consumer electronics. Household appliances is nothing but your TV. I told TV, nowadays the TV is nothing but your smart TV. Nothing but it can interact with your cable as well as it can interact with your internet connection. Okay, nothing but we call that as smart TV. That is also is nothing but embedded system. DVD players, washing machine, microwave oven, refrigerator, all these are nothing but what? The example for your embedded system in the comes under the household application. Okay, and similarly, home automations like your door lock, automatic door lock, television camera, CCTVs, okay, alarms, okay, yes, yes, air conditioners, okay, all these are all again the example for your embedded system here. Again, in the industrial levels, anti-lock braking system, whatever you are going to see in nowadays the two-wheelers brake, whatever you are going to apply using brakes in your two-wheelers, that is we call that as anti-lock braking system. Engine control, ignition system, automated ignition system that is implemented in your two-wheeler vehicle. Nothing but by pressing ignition system in your two-wheeler automatically start without kicking your bike. That is nothing but ignition system. Again, that is also example for embedded system. Automatic navigation systems. Okay, so I wish this is few examples of embedded system. I will discuss some more examples in the next session. Okay, I am going to discuss some more examples in the next session. Let me take the attendance for now. Okay, you tell me the answer for your attendance. Adam,
Present, sir.
Aishwarya,
Present, sir.
Akash,
Present, sir.
Akhilesh, okay, Alva,
Present, sir.
Anusha,
Present, sir.
Kirti,
Present, sir.
Bhargav, Dinesh,
Present, sir.
Chaitanya, Chandan Kumar,
Present, sir.
Chandana,
Present, sir.
Sharan,
Present, sir.
Sharan, Sharan, yes, just mute your phone.
Yes, sir. 1 second.
Sharan is present, sir.
Sharan HR,
Present, sir.
Sharan yes,
Present, sir.
Chetan yes, Chinmay BC,
Present, sir.
Darshan AR, Darshan D,
Present, sir.
Dhanyashri,
Present, sir.
Divya, Gagan, Gagan,
Present, sir.
Hemant CM.
Present, sir.
Hemant CS. Hemant CS. Jai Arsha. Jai Arsha.
Present, sir.
Sir, they are present.
Absent.
Jai Arsha. Jai Arsha. Hemant CS.
Present, sir.
Mute your
Sir,
phone. You are not here.
Sir, Darshan, they
Sir,
are
present,
present.
sir.
Jivita MN.
Sir, I am present.
Present, sir.
Okay. Kishore.
Present.
Krutika AR.
Present, sir.
Kusuma BK. Kusuma BK.
Present, sir.
Nikita.
Present, sir.
Raghav Manish.
Present, sir.
Madan BB.
Present, sir.
Mahendra.
Present, sir.
Mahesh.
Present, sir.
Manohar.
Present, sir.
Nandita.
Present, sir.
and Nikhil. Nityayan. Nityayan. Nityashri.
Present, sir. Present, sir.
Parnika.
Present, sir.
Pavan.
Present, sir.
Pavanayas.
Present, sir.
Rashanita.
Present, sir.
Donisha.
Present, sir.
Raghavendra.
Present, sir.
Rahul Rajiv.
Present, sir.
Raju.
Present, sir.
Rakshit PK. Rohan.
Present, sir.
Sania Zainab.
Present, sir.
Sandeep Kumar.
Present, sir.
Satvik.
Present, sir.
Shashank.
Present, sir.
Shashank HD. Shreya Gowda.
Present, sir.
Shreya V. Shweta Prakash.
Present, sir.
Sushti.
Present, sir.
Swati.
Present, sir.
Tejaswini.
Present, sir.
Srujana.
Present, sir.
Okay.
Sir, roll number 17 present.
Huh?
Roll number 17 present.
Why you are sleeping?
Sir, no, sir. Some network issue.
I know,
Sir,
no.
roll
I
number
know you.
15, sir.
I think you slept, had your lunch, and I slept, I think.
Sir, roll number 15 also present, sir.
Huh?
Roll number 15.
Chaitanya,
Yes, sir.
what you are doing when I am calling attendance?
Sir, sir. But you
Huh?
didn't hear, sir.
Okay, you can
Sir, roll
attend the
number.
next. You can attend the next class.